Hey class, so today's lesson is 7.8 applications with quadratics. Okay, a little bit of review. We know that a quadratic function is ax squared plus bx plus c. So this is the form that a function would have if it's a quadratic. So in today's lesson, we're going to be dealing with examples where an object is launched or thrown and we want to know when it would reach the ground. We're also going to deal with examples where we're trying to find the maximum height, as if somebody were to jump off something. We want to know what the maximum height would be. So we're going to have to do some change of variable here. We're going to do t instead of x for this because we're going to deal with time. 1 g t squared plus vt plus h. So you guys can see that our a is now -1/2 g, our b value is now a v, and then our c is now h. So let's actually write out what each of these variables mean. So t, like I said, that's our time. So how long does it take for the object to land to the ground? When does the person reach their maximum height? Things like that. The other one is our g. Now, g could be two things. It's gravity, but it could either be in feet or in meters. So this explains why this right here is negative, because we know that gravity pulls downwards. So pulls downward. And it could be two things. If we're talking in meters, it's 9.8 meters per second squared. And if we're talking in feet, it's 32 feet per second squared. So this front number here, your A, it's either going to be 4.9 or 16. Sorry, negative 4.9 or negative 16, depending if the problem's talking in meters or if the problem is in feet. So you just have to read to see which units you're using. And it's always going to be negative 4.9 or negative 16. Okay, the other variable we have is v. That's our velocity. That will be given to you in the problem, as well as your h, which is your height, and that will also be given to you in the problem. Both of these here are your initial. Keep that in mind too when working these problems out. It's your initial height, so what height are you starting at? And then it's your initial velocity, how much velocity are you initially starting at as well. These two things here will be given to you in the problem. Okay, so we're going to just move on to our first example. Okay, so here's our example. So suppose you were standing on an 80-foot cliff and launched a ball with an initial velocity of 64 feet per second. How many seconds will it be before it hits the ground again? Okay, when we're reading this problem, the first thing I want you guys to identify is feet or meters. So first thing is look here, and you guys can see it says foot there, and it says feet per second here. So we know that we're going to be dealing with the gravity in terms of feet, and we know that our gravity in terms of feet is 32. 32 feet per second squared. Okay, so as you guys can see in the picture here below, we can start labeling a few things. You're standing on an 80-foot cliff, so we know that this right here is 80 feet. And then initial velocity, so this right here has a velocity of 64. Okay, and we want to know how many seconds it will be before it hits the ground again. So we want to know what's going to happen or how long it will take before it hits the ground. Well, here's our ground. what do you guys think our height would be at when it hits the ground? Okay, yeah, the height would be 0. So here, we know that the ball, when it hits the ground, the height's 0. Okay, so as you guys can see above, we have our variables t, g, v, and h. Let's start going through and writing down these variables. T, g, v, and h. Okay, we don't know how long the time would be. That's what we're actually solving for. And then our gravity, like we said before, is over there, it's 32. Our v is velocity, and that was given to us in the problem. Velocity of 64, so v is 64. And then h is our initial height, so 80 feet right there. So we know our initial height is 80. Okay, let's kind of backtrack a little bit here. Our S of t, let's add that. S of t is our ending height. Okay, so add that back into your notes. S of t is our ending height. So looking here, when the ball is thrown and hits the ground, what's our ending height at? It's at 0. So our S of t is 0. So now we just go and write out our quadratic. S of t is equal to negative 1/2 gt squared plus v of t plus h. And then we just start substituting everything in. We know S of t is 0, that's our ending height. Negative 1/2 32 t squared plus 64 t plus 80. And we're going to start solving this. So what I like to do first is change this negative 1/2 times 32 to negative 16. And if you guys remember in the very beginning, I said it was going to be either negative 4.9 or negative 16. So if you want to start off the problems like that, go for it. Okay, and then for something like this, I would check to see if there's a GCF. So negative 16, 64, and 80, are they all divisible by a number? And they are. That number is 16. So I can actually take out, let's take out a negative 16, and that will give us t squared minus, so we can get two negatives to get that positive, and 64 divided by 16 is 4, so 4t, and then 80 divided by 16 is 5, so minus 5. If we were to distribute this negative 16 back in, we would get back to this quadratic here. Okay, so remember we can do the GCF to make things a little bit easier for us when we do our x method, because now on the top of the x is negative 5 and on the bottom is negative 4. That's much easier to figure out. We get negative 5 and positive 1. So now this factors to t plus 1 and t minus 5. Okay, and then now we can solve. So we set each one of our little factors equal to 0. So t plus 1 equals 0, or t minus 5 equals to 0. And then subtract 1, subtract 1. So t is equal to negative 1, add 5, or t is equal to positive 5. Now, if we're looking back at our original problem, we're trying to figure out when is the time here? When does the ball reach the ground? That was the question. Negative 1, can that happen? Can we have a negative time? No. So we know for sure that we can't have a negative time, so we know that we have to roll that one out, making t equals to 5 our final answer. And just make sure that you're tacking on those units. We know that this is in seconds. So make sure you write down seconds, and that would be the answer for this problem. Okay, let's move on to our example 2. Okay, so here is our second example. So say Superwoman was jumping off a 8-meter diving board. If her initial velocity was 24.8 meters per second, what would be the highest point she would reach on her jump? So remember what I said before, that you want to identify, is this meters or feet for this problem? So you can see here, it says meters, and also here. So we know that our gravity is going to be 9.8 meters per second. Okay, now this problem is a little bit different than our previous one. We want to know what the highest point would be when she would jump. So what is the highest point of a quadratic? Well, we can see that it is here at this point right here. Now, if you recall a few weeks ago, we talked about that point of a quadratic. That is called our vertex. Okay, we need to identify again what the formula for vertex is, and that's negative b over 2 times a will give us our x value, so that equals x, and then we can take that x and then get our y value. Remember that vertex is a point x comma y. So in this problem, we're going to have to figure out what that x value is and plug it into our quadratic to get that y value. That y value will be our maximum height. So let's first set up our quadratic. So we have to identify our variables, everything that we know. So in this problem, we have our gravity, which is 9.8. So G is 9.8. And if you guys want, we can say that 1/2 of G is going to be 1/2 of 9.8, which we know is 4.9. Okay, and then the next one that we need is our velocity. So our V, and that is given in the problem, 24.8, as we can see right here, velocity. And then she's jumping off an 8-meter diving board. That's our initial height. So our H is 8. But like I said, this problem's different. We're not solving for when she lands in the water here. We're solving here at the very top, the highest point. So we need to solve for the vertex. So now we're going to take all these values and we're going to write our quadratic out. So in this one here, S of t is equal to negative 1/2 gt squared plus v of t plus h. Now we can start plugging everything in. We know that 1/2 of our g is 4.9, so negative 4.9 t squared. Our v is 24.8, and our t is 8. Now we don't need to set this equal to 0. Again, this is a different problem. We're solving for the vertex. The vertex is our negative b over 2a. So that's what we're going to do with this quadratic here. I'm just going to give us some more room. So vertex is x is equal to negative b over 2a. We can see our a is negative 4.9 and our b is 24.8. So plugging that in, negative 24.8 over 2 times negative 4.9. When you plug this into the calculator, the bottom is going to be negative 9.8. The top is negative 24.8. And then dividing that is going to be about 2.5. But like I said, vertex is a point. We don't want to know how long it's going to take for her to get to the maximum height. We want to know what the maximum height would be. That's our y value. So we need to solve for our y, which is our s of t. And we're just going to take 2.5 and plug everything into our quadratic. So negative 4.9 times 2.5 squared plus 24.8 times 2.5 and then plus 8. Okay, so you can pause the video if you want to do all the calculations on your calculator, but when you multiply the 2.5 times 2.5 because it's squared, you get 6.25 plus, and I'll just rewrite the rest. Okay, now I'll multiply negative 4.9 and 6.25. That will give you negative 30.625. And then 24.8 times 2.5 is 62. We add 8. And then when we add everything together, we'll get about 39.375. And then I want you guys to realize that we're talking about this point right here. The point is going to be 2.5, comma, 39.375. Now, if we're looking at this like a graph, this right here is our time, and then up here is our height. So it's like our time and then our height. And going back to the original problem, we want to know what would be the highest point she would reach on her jump, and that's talking about the second number here. So right here is where our answer would be, but again, we have to make sure we put our units, and for this problem, it is meters. And then that would be our final answer, 39.375 meters. Okay, and that's it for this lesson. You guys will now do bookwork 7.8, and I posted that in Google Classroom. Okay, have a good day, everybody. Oh, and by the way, if you've made it to the end of this video, then kudos to you. And I'll give you guys your magic word for your mini test this week. The magic word for this week is Fiji. That is where my show that I'm currently watching, Survivor, is filmed at. So your magic word for this week is Fiji.